Greetings, mathematicians. Today we're looking at example 7b, writing the domain of a function in interval notation. This has to do with finding out what values need to be excluded from your domain based off of the denominator. So any values that make the expression of the function equal to undefined, or the denominator equal to 0. So this goes back to previous examples where we would be setting the denominator x minus 3, set that equal to 0, obviously add 3 to both sides. So x equals 3. This isn't a solution, this is the value that needs to be excluded from the domain. So it does say for interval notation. Interval notation is another way to express values or represent values. So we need to represent values from negative infinity all the way up to but not including positive 3, and then from positive 3 but not including positive 3 to positive infinity. So basically, let me show you that on a number line, for example. The only number that I care about is 3. However, it cannot equal 3, so I have an open circle there. I can have any value to the right of 3, and I can have any value to the left of 3. So basically, just if I had, let's go ahead and do set builder notation. It would be x such that x is a real number and x cannot equal 3. Let's make that a little larger there too. Why not? Okay, well, that messed that up. But that's the number line. This is set builder notation. Interval notation would be using the symbols that we used at the beginning of the semester, open parentheses, U for union. So I need all of these values and I need all of these values. So that's going to be open parentheses, negative infinity, comma, positive 3, close parentheses, because it's not including 3, so it's parentheses. If it did include 3, we would have a bracket on it. But then U for union, and it's just capital U, followed by open parentheses 3, comma, positive infinity, and that would be, this would be the interval notation for example 7b.